Welcome to MRL. In this learning session, we'll be learning about geometry, its development and contribution of Euclid to geometry. Now, what is geometry? Geometry means measurement of earth or measurement of land. Now, geo means earth, metro or metrane means to measure. So, the measurement of earth or measurement of land is known as geometry. The practical observation of the things surrounding us, the need of measurement of land and drawing the boundaries of land, construction of canals, construction of altars, the town planning, etc. contributed to the understanding and development of geometry. Now, what is Elements? Elements is a treatise of geometry written by Euclid. There are 13 chapters in it. Many mathematicians contributed in the development of geometry, but Euclid recorded the works of geometry in his treatise known as Elements. Remember that. Now, broad classification of geometrical figures. Now, we know that in geometry we learn different types of figures. We have got solids which have shape, size, they have a position, they occupy space and can also be moved. The solids are three-dimensional geometrical figures. Then next is we have surfaces. Surfaces or planes, they are boundaries of solids and form faces of solids and also separate one solid from the other, and they are two-dimensional figures. Then we have curves or lines, and they are the boundaries of surfaces or planes, and they are one-dimensional figures. The ends of the lines or line segment are points, and point has no dimension and it is a dimensionless figure. So therefore, remember, we have three-dimensional figures which we call them as solids. Then we have surfaces which are two-dimensional figures. Then we have curves which are one-dimensional. Then we have a point which has no dimension at all. So therefore, one dimension decreases as we move from solids to point. Remember that. Now, Euclid's definitions, axioms and postulates. So let us learn as to what is the Euclid's contribution to geometry in his definitions, axioms and postulates. Now let us start with the Euclid's definitions. Now, Euclid's definitions are a few of them. A point is that which has no part. A point is that which has no part. In simple language, a point is a dimensionless figure. Remember that. Now, a line is a breadthless length. That means a line has no breadth, a line has only length, and that is the meaning of a line is a breadthless length. The ends of a line are points. You know that every line has end points. The ends of a line are points, and that is the important definition. A straight line is a line. A straight line is a line which lies evenly with the points on itself. A surface is that which has length and breadth only. The edges of a surface are lines. A plane surface is a surface which lies evenly with the straight lines on itself. So these are the definitions given by Euclid in his geometry, in his the treatise called as Elements. Some words used in the definitions are abstract words which are not defined and are accepted as they are or understood with the help of physical models. Now, the important term used by in geometry are axioms. Now, axioms are general statements. Axioms are general statements that are accepted as they are without discussion or proof. Now, we'll be discussing about axioms again later with greater details. Now, Euclid's axioms. Euclid again gave a few axioms. Now, things which are equal to the same thing are equal to one another. This is a very important axiom. Things which are equal to the same thing are equal to one another. A very simple axiom, but very much true. If A is equal to B, C is equal to B, then A is equal to C. Okay, that is very important. So, things which are equal to the same thing are equal to one another. Remember that. Now, the second axiom is if equals are added to equals, the wholes are equal. If equals are added to equals, the wholes are equal. Now, if we have line segment AB equal to line segment CD, we have line segment PQ is equal to line segment RS. Now, if I add PQ to AB and RS to CD, then the length of the line segment, the sum of which is AB plus PQ and CD plus RS, both are equal. So, equals when equals are added to equals, the wholes are equal. Now if equals are subtracted from equals, then the remainders are equal. If we have again AB is equal to CD, AB is the line segment and it is equal to the line segment CD, then we have two line segments, PQ is equal to RS here. Now if I subtract PQ from AB and RS from CD, we again find AB minus PQ is equal to CD minus RS, and that is what is the axiom there. Now things which coincide with one another are equal to one another. Two circles of same radius. So if you have two circles of same radius, they superimpose or coincide and the circles are equal to one another. The whole is greater than the part. 100%. A circle is greater than the sector of the circle. A very good example for us to which explains that the whole is greater than the part. Things which are double of the same thing are equal to one another. Things which are double of the same thing are equal to one another. A very important axiom again. Things which are halves of the same thing are equal to one another. Again a very important axiom. So please remember these axioms, and these axioms are very much true. We can go for some practical examples and understand these axioms. Remember that. Now Euclid's postulates. Now what is a postulate? A postulate is a statement based on observed facts, and the truth is given by actual construction and measurement. So there is no logical proof, but by actual construction and measurement we can prove or explain the postulate. Now what are the important postulates given by Euclid? The first one is a straight line may be drawn from any one point to any other point. A very simple postulate here. A straight line may be drawn from any one point to any other point. That means in simple language there can be one straight line between two distinct points. It means given two distinct points there is a unique line that passes through them, or only one line passes through two distinct points. Now if we have P and Q as two distinct points, then only one line L passes through P and Q. So remember that. Now the second very important postulate is a terminated line. When I say terminated line, it has to be a line segment, can be produced indefinitely. That means if AB is a terminated line or a line segment, it can be extended on either sides, and it extends endlessly on both the sides, and that is becomes a line. Now a circle can be drawn with any center and any radius, but natural, any circle can be drawn with center, with any center and any radius. That is what is the important postulate here. All right angles are equal to one another, but natural, all right angles are equal to one another because the measure is 90 degrees. Each of the angle measure is 90 degrees. If a straight line, this is the important postulate, if a straight line falling on two other straight lines, let us read the statement first, then I'll explain it to you. If a straight line falling on two other straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced, meet on that side on which the sum of the angles is less than the two right angles. Now if you see here, AB and CD are straight lines, and there is another line PQ which falls on them, and if the sum of the angles, please understand this very carefully, if the sum of the angles on the is 1, that is 1 and 2, is less than 180 degrees, then the straight lines will meet on that side where the sum of the angles is less than 180 degrees. Remember that, means they will meet this side and not the other side. In the figure, if angle 1 plus angle 2 is 180, if angle 1 plus angle 2 is less than 180 rather, then the lines AB and CD will meet on the side where the sum of the angles is less than 180. The lines will meet on the left side of PQ. That is what is the figure, and that is what is the statement.